So on to Dakota's sprint, a question, the type of question at least that a lot of people struggle with. It's a little bit difficult, or I think we find it intuitively quite difficult to come from one description of kinematics to another. So if we're dealing with velocity and time, transforming that into acceleration and displacement can really be a tricky one, but I think with a little bit of practice it's actually quite straightforward. So in this question here, important to read the question, we're actually asking around displacement, and I'm giving you velocity and time. Now obviously displacement is related to velocity and time. In fact, over here we might just say that displacement equals velocity multiplied by time, which of course is just a reworking of velocity equals displacement divided by time. Remembering that this is a change in displacement and a change in time and our average velocity. So the same thing here, average here, a change in and a change in. Now that presents up with a number of ways of calculating this, and there's ways that we can do that, you know, very complicated ways, and there's also some very simple ways of doing it. Probably the most intuitive way that I find to do this is to look at each of the seconds in the time period asked and figure out what the displacement is for each of those based on the average velocity. So what I mean is between the 2 and 3 second mark here, I can see from this graph that the average velocity is 3 meters per second. So we're going 3 meters per second over that whole time period. And so for time point 1, or maybe make it easier, say between 2 and 3 second marks, the average velocity equals 3, which means therefore that the displacement, if the average velocity is 3 meters per second and it's over 1 second, then the displacement is going to be 3 meters. So we've traveled 3 meters in that first second. Now from the 3 to the 4 second mark, we start at 3 meters per second and we finish at 5 meters per second. So the average velocity between that period must be 4 meters per second. So from the 3 to the 4, our average velocity must be 4 meters per second. So therefore our displacement over that second would have been 4 meters. In the final time period, in this one here between the 4 and the 5 second mark, we can see our average velocity must be 5.5 because we start at 5, we finish at 6. So our average velocity is 5.5. Therefore, the displacement is going to be 5.5. Again, that velocity over 1 second is just the same. So 3, add 4, add 5. So the total displacement over those 3 seconds must be these added up to equal 12.5 meters. On to part B. Dakota's instantaneous velocity at the 4.5 second marks. Again, it's really important to read the question. So here we were being asked for displacement and we were giving velocity. Here we're asked for velocity, we're already given velocity. So it's actually on this chart already. So at the 4.5 second mark, if we look between 4 and 5 at the 4.5, we can actually see it's going to be 5.5 meters per second. So we actually don't need to do any calculations. We can just say 5.5 meters per second. What's Dakota's average acceleration between the 1 and 4 second marks? Well, acceleration equals change in velocity divided by a change in time. And so in this case, the change in velocity between the 4 and the 1. At the 4, the velocity is 5 meters per second. And at the 1, the velocity is 2 meters per second. And then with respect to time, the 4 second mark is the second point, and the 1 second mark is the next point. Now that's 3, and that's 3, and so we're essentially going to have 1 meters per second as the answer.